Okay, so this is lesson 4 for chapter 4, and it's all about functions. All right, so really quick, I want to review what we talked about yesterday in the last lesson with domain and range and kind of the other names for them. So again, I want you to write down in your notes domain. And right now I want you just to take the next 15 seconds and think about any other way we know how to say domain. Hopefully you came up with a few ideas. Remember, our domain is always our x values. Since it's our x values, it means that's what we are plugging into the equation. So that is going to be our input. And since it's our input, that means it's the independent variable. Okay, our input is our independent variable. That means that this could be anything as we're plugging it in. It does not depend on what the other value is. Where our range, go ahead, and this time I'm only going to give you 5 seconds because you should kind of understand what this is going to be based off of what the others are. Hopefully you were thinking ideas of this is like our y value, or as a function. When we write it in function notation, that's going to be our f of x. Remember, they really mean the same thing. Our y is what we get when we plug x in, and this is just saying this function, we'll figure out what this is when we plug in this x value. So they're saying the same thing, they're just represented different ways. Okay? Then instead of our input, this is going to be what we get after we plug something in, so this is our output, which means this answer depends on what we plug in to it. We get out dependent on what we put in. So this is the dependent variable. Okay? And so when we look at functions, it says sometimes functions are written using two variables. One variable, usually x, represents the domain, and the other, usually y, represents the range. When a function is written in this form, it is an equation. Like equations, functions can be represented in words, in a table, with a graph, and as ordered pairs. The graph of a function is the set of ordered pairs consisting of an input and the corresponding output. Okay? So today we're going to kind of look at functions with their tables, and we're going to use the idea of like a function machine of where you are plugging things in and getting an output. So I'm going to have the substitute pause the video here and show you another just kind of a fun video to understand the idea of a function machine. All right, so you've watched that video, and if you didn't watch the video, the idea of a function machine is kind of like our calculator. Okay, the idea is we plug a number in, we get a number out the other side, and it's dependent on whatever function the calculator is saying. So we kind of use this table as the idea of a function machine. This is what we're plugging in. It goes through this as the machine, and then this is what we get out, okay, as we go through. So when we're looking at this first one, it says the school store sells book covers for $2 each and a notebook for $1. Tony has $5 to spend. The function is y equals 5 minus 2x, represents the number of book covers x and notebooks y she can buy. Graph the function and interpret the points graphed. So the nice thing about today is you are not actually coming up with the functions yourself. You're not having to create the linear equations at all. They give them to you. Okay? So when they give it to you, they're going to expect that you create the table. So we've talked about tables and plugging numbers in before, but you have to create this table today. You have to create this idea of a function machine. And then you plot the points that you find. So 0, 5, they plotted that point. 1, 3, plotted that point. 2, 1, plotted that point. 3, -1, they plotted that point. Okay? Now, one of the things that you need to think about for this is, since it's a story problem, not all numbers will apply. So when you're thinking about what to plug in as your domain, your input, think about what these things are talking about. So this input here is talking about book covers. Okay, so notice we're not putting in any decimals because you can't buy half of a book cover. The other thing is I didn't put any negatives in because I can't go to the store and buy -1 book covers. Okay, so they started at 0 because you could buy none of them, and then 1, 2, 3. And eventually they stopped because here I was then getting a negative number. And my y values, remember, are talking about notebooks. I can't have a -1. So when it says to interpret the points graphed, you're just thinking about them as what they're actually talking about in the context of this problem. This one is saying she went to the store and bought 0 book covers and 5 notebooks. Here she went to the store and bought 1 book cover and 3 notebooks. Here she bought 2 book covers and 1 notebook. And this one we can't actually do since she can't buy a negative amount. Okay? So that's what they wrote out here. That's the interpretation. I always have people that struggle with that idea of what does it mean interpret? That's the interpretation right there. Okay? So we're going to look at the got it together because sometimes people look at this and they're like, I'm not really sure what I'm supposed to be doing here. It's not that the work's hard. I'm just confused what I should be doing. So it says, the farmer's market sells apples for $2 per pound and oranges for $1 per pound. That's just kind of context here. Even the next sentence. Marjorie has $10 to spend. All context because they're just telling you where they're coming up with this equation and what it's talking about for this story problem. So you don't actually have to use that to create the linear equation like we've had to do earlier in this chapter so far. The function y equals 10 minus 2x, so I have $10 and I'm going to spend some amount here. Okay, represents the number of apples, x, because it's $2 per apple. And what that leaves me with was how many oranges I can buy because it's $1 per pound, so it's really like a 1y here. Graph the function and interpret the points. So when I look at this, the first thing that I want to do is create a table. So I want everybody off to the side. It's not that difficult to create a table, I promise. Okay, we have our x, we have our y, and remember this is like our function machine, so this is going to be my function here. It told me to get to y, I have to do 10 minus 2x. Okay, I always have people that put equals y in here, but that's really what this part is. This is going to equal my y value then. Okay, and again, since we're talking about things I'm buying, I can't have a negative numbers, so I'm just going to start off with 0. I'm buying none of them, and go positive. Okay, so as we go through, my function machine would plug this in and it would say, okay, 10 minus 2 times an x of 0. I'm just going to go ahead and fill all of them in right now. And then I want you guys to pause the video, fill the rest of these in, and plot your points, and then restart the video. So hopefully you're finding 10 minus 2 times 0 is 0, so 10 minus 0. This would really be 10 minus 2. Please make sure if you're doing the mental math that you do the multiplication before subtraction, because PEMDAS tells us we multiply first, so you should really be doing 2 times 1 is 2, so 10 minus 2. Oh, and I wrote 2 then because I was saying it, I'm sorry. So this would be 10 minus 4, 10 minus 6, 10 minus 8, and 10 minus 10. So I plot my points, 0, 10. You did have to be careful on this because I had a 1, and that's right in between here. So 1, 8, 2, 6, 3, 4, 4, 2, and 5, 0. Okay, so that's what that would look like there. So we have made the table. We've graphed the function. Now we have to interpret the points. And I'm not going to make you write all these sentences out, but you need to actually be able to tell me what each point represents. You will have an IXL that it'll say, you'll have your graph, and it'll say something about, okay, what about when there was 2 pounds of apples? Okay, so then you have to say, okay, X was my apples, so I'm going to go 2 pounds of apples. That means that I had 6 pounds of oranges. And you'd basically just read through that, each one. So if I buy 0, or I guess I'm sorry, it's $1 per pound. So X is just the number of apples and the number of oranges, not the pounds. So if I buy 0 apples, I can buy 10 oranges. If I buy 1 apple, I can buy 8 oranges. If I can buy 2 apples, I can buy 6 oranges. I don't have any money to go over 6 oranges because this would be $2 per pound, that's $4, and this is $1 each, okay? So if I buy 3 apples, that's going to be 4 oranges. 4 apples, I can buy 2 oranges, and if I buy 5 apples, I can't buy any oranges. I'm not going to go to 6 because then I'd get negative numbers. We can't have any negative amount when we're purchasing something, okay? So we look at the next one, and the next one...
Attention, 8th grade students.
Okay, sorry about that. And I did pause it for more than a minute, so I actually don't know what I was saying at the end. But I'm just going to start talking. So if I say stuff again, I'm so sorry. So from this one, the next one we're going to do is this exact same thing, except now we just don't have the context of it. So we're still going to make our function table. We're going to plot our points. We just won't have the interpretation at the end. Okay? So on the next one, we have our function. They said make the table, and I'm only going to require you to do this much of the table to have your input, your domain, okay, to have your output, your range. This is the function part of it, what I'm doing to get my y, and if you want to add this out on the end, you can, but I'm not requiring you to because all it is it's your domain and your range put together as your point. So that you know when I plug x in, for 0, 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So my point is 0, 2, 1, 3, 2, 4, 3, 5. And then you graph them. So 0, 2, remember you always do your x-axis first, then your y-axis second. So 0 and then 2. 1, 3, 2, 4, and 3, 5. And then once you graph it, notice there's a little difference that we'll get to at the end about if there's a line or if there's not a line. So for right now, you're just going to put your line. So if you need to take a second and get your straight edge out, feel free to do so. All right, so our got it's down here. When you do your got it's, I want you to actually create these function tables like we were just doing. Okay, so I want to see your x, your y, and your function in here. Your x, your y, and your function in here. So right now I just want you to take, I don't know, 10 seconds and write your function in for both of these. So your function, hopefully, you were putting in this section of each equation. So it's x minus 5, and this one is negative 2x. The next thing is you have to think about what's going to be your input. Since we have no story here, can we use negatives? Hopefully you're nodding your head yes. We can use negatives because we have no context to know if we're talking about a negative amount we're purchasing or something like that, or negative time is something you can't have, okay? So when you're looking at this, I always tend to do one negative, and I make it easy on myself, and I say, okay, -1. I tend to do 0, and then I tend to do 2 positives. And again, I make it easy on myself and pick the smallest positives possible, 1 and 2. Okay, so these are the ones I want you to do, and honestly, that's always a good idea to use those 4. If you have to pick points yourself, I would always pick those 4 because they're small numbers, they're easy numbers to work with. You have negative, you have 0, and you have positives. Okay, so go ahead and just fill in the table. You don't have to worry about graphing yet. So go ahead and pause the video and fill in the table. Okay, and I know I didn't put like all the lines in. If you need that to help keep yourself organized, feel free to add those in, but otherwise just try to write them kind of in a line across, okay? So you can say these out loud as I'm going through. -1 minus 5 is, 0 minus 5 is, 1 minus 5 is, and 2 minus 5 is. On the other one, we're taking -2 times each number. So -2 times -1, -2 times 0, -2 times 1, and -2 times 2. Okay, and now you're just plotting these points. So you're going to go up on each one, and you're going to say, okay, this point is -1, -6. So on my x-axis is -1, so backwards would be -1, so to the left, and then -6 for my y would be down. 1, 2, 3, 4, 5, 6. Okay, once again, go ahead and pause the video and fill in the table, or I'm sorry, the graph for both of these. So this is what it will look like for you. Remember I said at the end that you're going to put lines on these right now because you don't know the context of the problem. So we really could be picking out any number we wanted for the x values. Okay? So the next part, and if you need to, pause this to check a little bit longer. The next part then says representing functions. So it says the value of y is 1 less than the corresponding value of x. So it put it in words, then it put it as an equation, 1 less than x. It made the table. It wrote out ordered pairs even, 0, -1, 1, 0, 2, 1, and 3, 2. And they have their graph here. Okay? So it says a linear function is a function in which the graph of the solution forms a straight line. You guys know that. Linear means line. Therefore, an equation of the form y equals mx plus b is a linear function. We've had that so far. Y equals mx plus b. Okay, even on these. Y equals mx plus b. Y equals mx, and really b value was 0 there. That means that's just going to be a proportional linear equation. It's going to go through the origin. Here's 2 new vocabulary terms, though, that you need to know. It says a function can also, or can be considered continuous or discrete. Continuous data can take on any value, so there is no space between data values for a given domain. Discrete have space between possible data values. Graphs of continuous data are represented by solid lines, and graphs of discrete data are represented by dots. So I want you to write this off to the side here. Okay, continuous, and you're going to put that continuous means it can be a fraction, it can be a decimal, and it means there's always more values. When we do this, our line, when we have points, will be connected. So our linear function will have a line going through it. Okay? Again, if you need to, pause the video so you can get all of that down. Then we have discrete. And again, I want you to write this down. Discrete, you will have whole numbers. That means there will be no values between, and they can be counted. So for this one, it's going to be points like this, and they will not be connected, okay, because we can't do these values in between the whole numbers. We can't do the decimals in between. Like if this is 1 and this is 2, I can't do 1.5 in between. So there is no line connecting them because these are individual points that work for that linear function, okay? Now I want to talk about some examples of this. So it says the number of ounces in a glass is continuous, okay? As you're putting in your water bottle in the drinking fountain out there, you can put your water in and water's just going and you randomly stop it. It's not going to randomly stop at a perfect 1 ounce or 2 ounces or 20 ounces, okay? Most likely it's going to be like 20.36 ounces or whatever that is, okay? So when you're filling something up like that, there can be decimals there. The weight of a chocolate chip, okay? Again, when they're making those in the factory, the goal is to get everything a perfect size, but as they're making them, they're like dropping the chocolate down, and so the weight of it is going to be not a perfect number. It's not that it's going to be exactly 1, 2, 3. It could be 1.28. Okay? Think about your own weight when you go to the doctor and they take your weight or your height even. Okay? Not everyone is exactly 5 feet and then you jump to 6 feet. Okay? There's in-between numbers there. So continuous data is really when there's in-between numbers. And discrete is when there's not in between. You can't have a half. Okay, the number of glasses in a cupboard. If you open up your cupboard at home tonight and you count the glasses, you're not going to count 1, 1 1/4. Okay, and I always have some people who try to be smart and say, but one glass is smaller than the others. It's still a whole cup. Okay. The number of chocolate chips in a bag. We've all opened up a bag of candy before and there's like that half piece or quarter piece in the bottom of the bag. Sometimes that happens, okay? But that's still 1, all right? We count it as 1 piece. Even though it's smaller than the other, that's still 1 piece of candy, okay, or 1 chocolate chip. So continuous data, some examples of things like that would be like height, speed, time, amount of rainfall. All of those have decimals and fractions to them when they're measuring. This is more like counting the amount of things, like the number of cars, or even if you think of shoe size. Yes, you might be like, well, Mrs. Lumley, I'm a 9.5. Yeah, but there's no 9.3 shoe size, okay? This is, again, counting things like number of family members. All right, that's the difference here.